right, so in our earlier sections, talking about routing, getting our routing set up on our firewalls. Next, moving on to additional filtering, setting up some access list filtering information. Again, quick review on the filtering. The state table looking at traffic that is watched, what traffic is inspected, going from the higher security interfaces to lower security interfaces. Some protocols inspecting by default, other protocols not. One of those examples that is not would be things like ICMP. So ICMP not inspected by default. Because of that, having to be handled a little bit differently. In the earlier example, we looked at a little bit of just adding inspection rule into policy itself. Alternatively, could also just look at, for the ICMP, again, having just a access list on the interface itself. Get an access list allowing that in the outbound interface, then that traffic would be allowed to pass from the lower security numbered interface to a higher security numbered interface. For the scope of the lab, make sure you read things very carefully as far as what you're told to do or told not to do. For the most part, they generally seem to be fairly flexible with allowing ICMP for, say, ping testing. So unless they say otherwise in the lab, you may think that's okay. Again, if you're not completely sure, you can get clarification from the proctor. Ask them if it's okay to allow perhaps echo and echo reply traffic for connectivity testing throughout your topology. Getting into access lists themselves, if you're not getting into policy adjustments, filtering adjustments, you can also do just the access list on your interface. For the most part, your access list syntax is closer to iOS than earlier versions were. However, some slight things different. One of those being that using the subnet mask rather than the wildcard mask when compared to how it's done on a router, and also that you have less options in the context help. If we pull up a firewall here, bring up our ASA here. You have a list of a variety of items. Again, may or may not have what we're looking for. We do also have other listings for specific items as well in the configuration examples. So we're going to pull up some configuration items here. Case pulling up in the documentation. The Cisco Security Appliance ASA configuration guide. And under our configuration guide itself, towards the bottom, we do have options for reference section. A couple things to look for here, in this case, addresses, protocols, and ports. Particular section giving a list, common items, common addressing, subnet masks, address formats, different subnetting information for different mask lengths. Again, looking at how those lay out, mappings for what those address ranges map out to. IPv6 information as well, again, not in the scope of the security lab for now. That's something they could be adding in the future, but not anytime in the near future. But moving beyond that, you do also have a listing of protocol information, the literal protocol values, IP being a large grouping, having a number of sub-items that includes. So some of the more common ones, ICMP, TCP, UDP, again, those device items having their own literal protocol value. ESP, AH being two other common security ones. EIGRP and OSPF, two other ones. Again, it's not TCP traffic, it's not UDP traffic. It's its own separate protocol value. If you didn't know the protocol value, you could go here and look it up. You could also look it up on a router, or for ones that have name mapping like ESP, and look it up on the devices themselves. In addition, you have a value of TCP UDP ports. Again, a variety of listings for these various items. Again, Read through your section carefully. You may be given the port numbers to use. It may be something that's predefined with a port number here. It may be something that you need to go in and just match by the specific port. Other general miscellaneous things, traffic used locally on the devices, what items they're using, what traffic they're using, and how those are set up. In addition, we also have a listing here for ICMP types. So ICMP types on the device, in case you didn't know what the ICMP type was for a certain type of information, or you're given a specific type code to use or to block. If I say block ICMP type code 12 and you don't know what that is, if you want to look that up, you can look it up here. Again, this is the reference section under the firewall security appliance configuration guide. So a variety of different information, types of items listed there. Again, be familiar with the configuration that you do have access to in the lab. Very good overall general reference for protocols, ports, things like that. In addition to looking at the firewalls, you can also look at the items on a router as well. We do the same thing on a router. Router 3. And looking at something on a router itself, looking at the built-in list, the routers themselves having a fairly good list of various common protocols, common ports that are being used. So a variety of different ways, different places you can look things up. Again, look at your devices, look at your configuration. Sometimes it's easier to check just like this on a router itself rather than trying to click through the documentation to where those other charts or items might be listed. So next we're going to look at some ACL examples. We configured some ping examples earlier, looking at pinging between router 6 and router 3, looking at different methods that can be used for that, whether to use the inspection for ICMP or possibly alternatively using the access list on the interface. So different methods. Also, we did mention earlier that difference between the ICMP command affecting traffic terminating on the ASA itself, trying to ping the ASA interfaces, compared to the access list entries for permitting or blocking traffic that is transit through the ASA, through the firewall device. We're going to look at some configuration on ASA 1. In this case, on ASA 1, going to look at some examples. Another feature of the firewall. That feature that we're going to look at is object grouping. Everyone familiar with object groups? Heard of object groups? Object groups themselves basically allow you to reduce repetitive entry for ACLs, able to group things together. So some of the different types of things you can look at can match by physical protocol number, so matching all TCP, UDP, or all GRE traffic. Matching certain networks, if I want to match by networks, subnets, possibly hosts, things like that. I can also get into matching specific services, service items, or also matching ICMP types. So in this case, if I just wanted to do ICMP echo, echo reply, then I can do that. So different types of things, different types of items. The general benefit of object groups is generally gets into scalability. So if I have, say, some web servers, and for the web servers, I want to allow traffic on port 80 for HTTP and traffic on port 443 for HTTPS. Well, in the future, I may have another web server added in. So rather than have to go in and add an access list line entry for allow traffic to that server or from that server, port 80, allow traffic to that server for port 443, I have my object groups configured and I have an object group for my different items, then I could just have an object group for my devices and have a list of web servers, an object group for my protocols and have a group of protocols, and say anything from this devices with anything with this particular service. So potentially could be as simple as if I have a new web server coming online, adding that new web server's IP address to the object grouping that I have for the web servers, and by doing that, having that access allowed through. Because of that, you can run into some issues or some concern as far as trying to interpret the data. You get into multiple items. If I have two services, in this case, the port 80 and the port 443, and I have 3 hosts, then I total have a combination of 6 combinations. So any of the first 3 and any of the other 2, it multiplies, so 3 by 2 is 6. I was also matching other items for source and destination. It could multiply more and more and more. In my configuration, it just shows up as one line in my config. However, it actually looks through every possible combination between those. We'll look at that in a second. So in this first example, we're going to start off with our object grouping. Again, different types of object groups there. Again, talking about things like the core knowledge or the beginning questions. One sample question or type of question you could get, it could be to list the different types of object groups available on the ASA. So knowing that you have protocol object groups, network service, ICMP type, and you do also have another one that's not listed in this list of 4 here. You can also do an object group of a group. Will allow you to nest items. So if I have, say, an object group for my web servers, and I have another object group for, say, some database servers, I could nest those 2 groups into a third group and then reference that nested group. So if I want anyone to be able to ping my web servers or my database servers, I could nest both those object groups into a third group and then just reference that master group that contains the 2 subgroups, basically. Different types of things you can do with those. In our example here, we're going to go ahead and get to some configuration. We have our AAA server here. We want him to be able to ping and send ping replies to router 5 and switch 2. Telnet web browse to router 5 and switch 2. And reply to requests. We start off looking at our different items here. We have some for ping, telnet web browsing, NTP, and TFTP. Again, some places you may want to get clarification. Or something like web browse, you may want to get clarification, say from a proctor. Should I be allowing both port 80 and port 443? Does web browse just mean HTTP? Does HTTP and HTTPS? Is it one or the other? For the scope of the lab, as a general rule, overconfiguration will not hurt you as long as it doesn't break another section. That's something that they will tell you. If you're not quite sure on something, extra configuration, as long as it's not breaking something else, isn't going to hurt you. In this case, if you took web browse to mean port 80 and port 443, most likely that would not be counted against you. Ideally, get clarification from the proctor, but more than likely that would not cost you points. Now, if you tried to pull the argument of, well, I didn't know what port they wanted to browse on, so I just did permit TCP any, more than likely you're not going to get the credit for the section. So within reason, overconfiguration isn't going to hurt you. So we're going to start off, we're going to create some object groups and object items. So in this case, we're pinging and sending ping replies, router 5 and switch 2, telnet web browse, router 5, switch 2, and then also replies. Go ahead and pull up our window here. Now, as far as other questions we might want to ask, anyone think of any other questions you might want to ask the proctor in this particular case? Telnet and ping are pretty straightforward. Web browse is pretty straightforward. However, it does say to router 5 and switch 2. You may want to get clarification from the proctor whether you're allowing it to any addresses on those or just specific addresses on those. In this case, we're going to be a little bit more restrictive and just use our loopback addresses. In this case, pulling up our telnet window, pulling up information on our switches themselves. We do show that for those two devices, the loopback has an address of 150.1.5.5 on router 5, and the switch having a loopback address of 150.1.8.8. Again, we're going to assume that we got clarification from the proctor. If they just wanted to ping the loopback, if you're not sure, if you need to allow it for all addresses, then you may need to use just a regular access list. As far as granularity, if I'm supposed to match a .5 and .5 and a .8 and .8, technically that can be done in a single line with an access list. However, you will be matching other items because of the way the bits fall and it's not all lining up properly with a binary. So in that case, having the object group entries is generally going to be cleaner because you're more specific as far as what you're actually matching. So we're starting off setting up our object groups for our ping and ping reply. In this case, it's going to be object group. At our types, it's going to be ICMP. And we're going to give it a name. We're just going to call it ping. And with that, we have other sub options for that. In this case, with the ICMP type, looking at our options, we have group object if we wanted to reference a group, and being able to group sub items together, or ICMP object. We're going to go ahead and just use the ICMP object. And for the more common items, having those listed by names, other ones having listed where you can enter a type number. And we're just going to go ahead and do echo and echo reply. Now we have an ICMP object configured. Next, we're going to configure a object for our telnet and web. We can go ahead and exit out of this one. Call this tel web. Actually, we're going to do that slightly different here. Service object group. P. In our options, these are port objects. and a variety of different items. In this case, we're looking at HTTP, and we're also doing HTTPS, and I have one for Telnet here. NTP, TFTP. Again, another place you may want to get clarification, NTP could be something that's done as TCP or UDP. We're going to assume it's just UDP, assume we've got that clarification from the proctor. Not sure if it has a definition for that. It does have an option for NTP. TFTP, again, those ports 123 and UDP 69. If you didn't know those, then you can also, again, look at a router itself and look at it that way. So we've got ping replies, router 5, switch 2, telnet web browse, NTP, TFTP. Next, we're going to set up a group for those devices themselves. In this case, the grouping for router 5 and switch 2 going to be the network object group type. And we're just going to call this R5 switch 2. We could call it anything we'd like. In this case, we could be adding other ones in the future. For now, we'll just keep it like that. These are network objects. You can put in address and mask, so you can put in host and then a specific address, 151.5.5 for router 5, and .8.8 for switch 2. Taking a look through, we have our object groups here in our configuration. Next, we're bringing it all together in access list entries. Before we get into too far in access list, stop and look at where our devices are, which interface they're on. In this case, the AAA server is on the DMZ interface. Case, take a look at our security levels that we have here configured. Our DMZ interface does have a security level of 0. We're going to go ahead and change that. If we wanted to keep that as a security level 0, we would need our same security command on there. Go ahead and just change that security level to 50. Now our DMZ is at a different level than our inside interface. So it's the interface that is not as trusted in this case. And we're permitting from the AAA server, so from the host of 10.0.0.100. In this case, I can get into matching my object group, or I could be matching the other host. In this case, my network information here, the network object group. object group that I had predefined. In this case, looking back at my earlier definition for my network devices. My network device is defined as R5 switch 2. So I have my source address being my host 10.0.0.100, destination being the object group router 5 switch 2, and in this case happens to also be my port being the object group that I have defined for my port. That was telweb for my telnet and web traffic. A second entry here. Second entry is going to be for my UDP traffic for the NTP and TFTP traffic. And an entry for my ICMP. Now, in this particular case, we are told to allow this traffic with object groups. So it's specifically telling us to allow the AAA server to ping and send ping replies with the object groups. So in this case, doing an ICMP inspection may not get you credit for the section. In this case, an ICMP inspection would not really be using the object groups in order to allow that traffic permitted through. In this case, that's ICMP object type. Again, host of 10.0.0.100. The object group R5S2. And again, for that one, the object group type had defined was ping. Now if we do a show access list, we have a long list of items, again showing line 1, line 2, and line 3. For the individual items, we can also do a show run access list. Show run access list showing us the shortened versions, being the versions that were physically typed in. So in this case, we have 3 access list entries, but because of the way the items are populated, each of those individual lines gets split out in the show access list to show what each of the different possible permutations is for those. Got our access list configured there. Next, we need to go ahead and apply it to our interface. Again, that was the DMZ interface. We now have an access list applied to our interface. Look at our AAA server. Now, in this particular case, this particular setup and the setup on the rental racks for our rental racks, we do have access to the ACS server by remote desktop for the scope of the actual lab. However, you would not have that much access to the actual ACS server. For the actual lab, you will have access to the ACS server just for the ACS portion, just via the ACS web interface, but not have full access to the ACS server. In this case, we do, however. We're going to start just verify we have route information, route print here. We have route information for the 150.1 0.0 network, 10.0.0.12, our firewall's address. So we're going to go ahead and try to telnet 1.8.8. We have verified that we can telnet to switch 2. We're also going to verify that we can telnet to router 5. Burned our reachability to router 5. Should be able to ping as well, but just make sure that you do test. If you have multiple items you're asked to do, make sure you do test each individual item. If for some reason we had forgotten the ICMP, even though we had the other ones for telnet and web traffic, could lose points for that section. We do also have obviously a web browser here, so we're going to pull up a web browser, see if we can connect to those guys. Able to access the device there. See if we can access the other device. And able to access the switch as well. So able to access our devices, able to connect telnet web. For things like NTP, maybe a bit out of scope. If you really want to test that, you could configure in this case, could configure the AAA server and configure the devices for the NTP. So those NTP traffic is being allowed. By default, that's coming from the inside. We did explicitly permit those. However, that would be allowed by default coming from inside to the DMZ because of the security levels. Those being UDP traffic, which would be, again, inspected by default. The telnet web browsing to router 5 switch 2, that would be something initiated from the outside, so would need to have ACL entries for those. Any other questions on object groups, object group configuration, basic ACL setup? For the scope of the lab, make sure that you are very careful with your ACLs. ACL configuration can be very delicate. Make sure that you're careful to watch your traffic flows. Again, can get into looking at other traffic. Use things like your capture on your ASA. If you have traffic you're not sure is getting to the ASA, if the ASA is blocking, you can see, is it coming in one interface? Is it leaving out the opposite interface? So where is the traffic going? Is it passing through your device? Is it possibly being blocked by your firewall itself? In this case, we did have the ability to test, generally whenever possible. You have the ability to test from a device. Do what you can to test within reason. Don't go too far out of board. As far as time, again, keep track of time involved. But if you do have a basic quick check you can do here, it was just popping up a browser window and a command prompt. Check those and be able to verify that those were functional and working. Filtering for the lab exam. Again, keep in mind, traffic initiated from the outside, either outside itself, or if you have a DMZ from the DMZ to the inside network is considered outside. That traffic originated on those outside networks. By default, if it's originated on that side, going to be dropped unless there's an ACL match. So the ACL requirements may or may not be explicit on the lab itself. The radius server may be on the inside, it may be on the outside, it may be on the DMZ. So take a look at your drawing. Where are your devices? Where are your servers? They need to talk to. Look carefully at your topology. Look carefully at your layout. Again, you may have some areas work fine because it happens to be, say, inside a DMZ, or something else that's an outside a DMZ may not work. You may need to have other additional items configured. As mentioned earlier, have a drawing, keep your drawing separate, keep track of your network flows. So what flows do you have? What traffic is flowing? Where is it flowing? And with that traffic flows through the network, are there other things that I'm configuring in the middle of my topology that are potentially blocking those or causing that traffic to not pass smoothly?